Hi, I'm Raphael, GM at Truecaller Israel and Director of Product at the Cloud Telephony team. And today we'll talk about lessons we learned from building an AI telephony stack for 400 million users. And we'll start with the story. So basically, 6 years ago, 7 years ago, we noticed that speech-to-text models hit a milestone of around 5% error rate, which is similar to humans' error rate. And we understood that's a game changer. And there's a lot that we can do with it. So we set out to build a phone assistant that answers your calls for you and filters spam and scam and lets you know when important calls come in. But then we started working on it. We built it with a mixture of machine learning models and NLP conversation engine that we built. And when we launched it, users liked it, but we got a reality check that more than 70% of callers didn't engage with the assistant. It sounded a little bit robotic. They thought they were speaking to an IVR, and no one wants to speak to an IVR. But still, users liked it, and it started evolving. And then we were approached by the Truecaller, the caller ID app company, with around, at the time, 350 million users. And they said, that's a cool demo. Now, can you make it work for 400 million users? And yeah, we said yes. We were acquired, but then there was a plot twist. So we needed to build that phone agent, but for the Indian market. And it had to cost less than $1 a month, support a dozen of languages, and basically, do the impossible. So, our first thought was, this is crazy. We'll never make it. And we started doing the impossible math, right? So when you build a phone agent, every component bleeds money, right? So you have the speech to text, you have text to speech, LLM inference, and the most important part, which is the telephony part, you pay by the minute. It's expensive, right? And even for a few calls a day, you get to a couple of dollars a month of pure costs. And that just doesn't work with the needs that we had to be at a price point of under $1 a month, including the profit margins. And that made us think, how can we do it, right? Like, how can we take that constraints and still build it? So basically, we started deconstructing the stack layer by layer. And with the thought of, if you can't afford it, let's try to build it ourselves, even if it's like almost impossible. So we started with the telephony part, which was the most expensive. We started with that. And we thought, it's very expensive. Let's ditch the SaaS, right? The Twilio and the likes, and build it ourselves, right? Take an open source telephony server, build it ourselves, go directly to the carriers, right? And start learning this world. So we got into this world, built our own platform, and cut the costs there by almost 80%. Then we did the same for speech to text, text to speech, LLMs. We just went open source and learned everything about hosting it ourselves and serving it ourselves. And the lesson here was, every vendor margin is our opportunity to take. And at the end of the day, it's simpler than it looks, right? It looks complex, but there's a lot of nice people out there that will help you on forums and stuff to go over the challenges. And as you can see, we built a carrier-grade telephony platform that can support thousands of parallel calls and be scalable, right? With the Asterisk open source telephony server, a call management server, and that connects to multiple services that we can plug and play and mix and match models as we need and as they evolve. And this was a very, very interesting challenge to overcome. The next challenge was the language support. So basically in India alone, for the phone assistant to be relevant and working, you needed to support a couple of languages. And not only that, users switch language mid-sentence, which is really fun and a fun challenge. And sometimes they have something called Hinglish, which is part English, part Hindi at the same sentence, very complex. On top of that, you add cultural nuances, right? How you greet the caller sometimes matters more than the accuracy of the text-to-speech and speech-to-text. So we set out and we just researched and found every single vendor, every single company in this space working on those languages and challenges in India. And we started testing them. But the problem is the vendor promises, right? We support Hindi, Marathi, and Kannada, and we do it at 90% accuracy. But that versus reality, it never adds up, right? Sometimes it was 60% at best. So what we went ahead and did, and we built our own testing platform. We understood this is going to be a crucial part to have the right models, partner with the right vendors. So we built our own testing platform where users, our own users who speak those languages could test those claims. And then we could easily and very quickly run through and test a lot of vendors until we found the right ones. And then we obviously use the mix and match approach where we use different models for different markets, and we kept updating them as soon as a new model came out. And this space is moving so fast that certain models that came out after we launched were so good, we immediately switched to them. And this kept the language issue under control, right? So moving on to the next challenge, and as you can notice, they start stacking up those challenges. In order for the assistant to be effective, we really needed to, one, know what the actual current spam and fraud categories are out there, right? What are spammers doing? What are scammers and fraudsters doing right now as they keep inventing new ways? And once we know that, also we need to be able to detect them fast enough in real time as the assistant is speaking to the caller, in order to alert the user before they come into the call and fall for the scam. So it's basically a cat and mouse game with the scammers as they keep evolving. So first of all, we had a secret weapon, right? We had hundreds of millions of users who report scams for us and help us know what are the scams. So that was really helpful. Community reports provide instant training data, but we needed to go a step further and also we built scrapers there's online databases of police reports, right? And these are given in really bad shape documents that we needed to OCR and really understand and structure that data into our training data, and then fine tune our models to be able to detect those spam and fraud scam categories. So basically we built this whole system that everything goes into one centralized fraud categorizer that builds a category, a scam and fraud category database that then also goes through a user feedback loop, so we can make sure those categories are correct and updated in real time. Now, as we move forward, all of these constraints that we had so far are starting to accumulate, right? So we're built on top of the telephony infrastructure, which has a lot of issues. It has bad audio quality, 8 kilohertz, and you have sometimes choppy audio, low carrier support of, you have bad reception, right? And you need to deal with all of that with the audio quality. On top of that, we need to be cost effective. We need to be careful for every token that we spend for every call, because it adds up really, really quickly. And in the end, we need everything to have language support. So with all of those constraints, we said, all right, but now also we need to make the agent smart, right? It can't just answer your calls and filter spam. We have this very smart agent that the user installed on their phone. How do we make it handle phone calls, not just answer them, but handle them? So if it's a simple request that has been made before, I can maybe train my assistant to handle it on its own, and I don't need to pick up the phone, right? So we went ahead and started reviewing and researching all the potential solutions out there. And what we ended up choosing is the multi-agent architecture, where there's one supervisor agent, a conductor, and then under that conductor, there's a lot of specialized agents. And each layer specializes in one thing and does it really well. Here we had the benefit of using small, fast, and very efficient models that we fine-tuned for our purposes with a lot of data that we have. And then basically how it works is the supervisor agent handles the call. And as the call progresses, it uses and talks to the specialized agents to be able to fulfill the task. And when they get the task, they have another layer of tools that they can use, which are regular deterministic code, obviously, set appointments, cancel appointments, FAQ, if there's information that we had before that you want your agent to provide to callers, and even a security agent that checks the permissions of callers, right? If it's your mom, your dad, maybe it has different permissions than just a random caller that isn't saved in your phone book, and you might not want it to have access to certain information. As we did that, we saw that with time, there's data that gathers, right? And why not make use of that data for the benefit of the user? So we built a self-learning layer of memory that runs in parallel to the call assistant agent, that conductor that we spoke about. So as the call conductor handles the call with the caller, the memory agent runs in parallel and categorizes the request that the caller is making, right? So if it's a category that exists already, great. We have an answer for that. If it's a category that doesn't exist, we go back to the user after the call, right, in the UI, and we ask the user, that's a new call. Would you like me to handle the assistant, right? To handle those types of calls in the future, right? And then the user can say either yes or no. If yes, you can tell the assistant how to handle similar types of calls. So for example, a delivery from Amazon, right? And they call and they ask where to put the package. So if this is a situation that happens a lot, you can simply tell your assistant, write to your assistant as it prompts you. How would you like me to handle those types of calls? You can tell it, I like it on the porch, but behind the chair so people don't see there's a package. Yeah, that's it. And the assistant then stores that in the long-term memory. And every next call that matches this pattern, the memory agent will be able to fetch that information to the call assistant agent to be sent to the caller. And this way, you basically have an agent that the longer it answers your calls, the smarter it becomes and the more it learns about your preferences, and it can answer on your behalf, basically, to every single call that you get, which is the end goal. A very important part of how we build those agents is building them with eval-led development. So everything we do when it touches LLMs and agents, we have tracing and logging from the beginning, and we have evals at every phase, from the design for offline evals to the pre-production and production, and evals from actual live calls. And what we do is we use code-based evals for deterministic issues, and LLM as judge for natural language evaluations, which works pretty well if you use the state-of-the-art model for being the judge. And we also have a part of human annotations, which I like to do daily. I just like to go over it and see, for subjective quality assessment, stuff that LLM can't do. And the combination of all of those makes sure that every single upgrade and improvement that we add, or every new specialized agent that we add, we can very simply just test it across all our evals and make sure that nothing breaks and that the models are behaving as expected. Also, what's important here is that the industry moves pretty fast. And as we know, new models are announced every day, and we want to keep up. And in order to do that and to upgrade the models, we need to really be able to do so with evals and make sure that the current prompts and the way we build the agents still holds up, even if we upgrade to a newer, better, smarter model. One quick tip that I can give here is that we went through a lot of eval platforms until we found the right one. And what I can suggest is just test every tool that's out there until you find the one that really fits you, your work, your product, and your team, because this has very big effect on the quality of the agents that you will have. And the platform that we chose, just for whoever's curious, is Langfuse, which doesn't mean it's the best, it's just the best for us. We have some more time, so I'll talk about another challenge that we had. As you have, it's the same problem with every new tech that is invented, like this one. How do you get people to actually use it, right? It's new, it's innovative, it's weird. What do you mean? Like, we actually had users say, what do you mean it answers my phone call? Like, it answers calls for me? It's kind of hard to wrap your head around it for users. And there's a lot of trust issues, right? My phone calls are personal. They're very sensitive sometimes. Is it recording? Is it like, where's the data stored? Yeah, so you need to have a lot of security and privacy efforts in place. But also, how do you convince users to try it, right? So one thing we did just a couple of months ago, after very challenging conversion rates, we built something we called the playground, which is the first touch point users have with the assistant. And what it does, it gives users with one click a way to engage with the assistant, talk to it as if they were callers, right? And get them to the wow moment before you even set up the product. So we built it, we added it to our product. It was pretty complex. Just click, talk to the assistant. The assistant immediately starts talking to you as if it were your assistant. And then you speak to it, you understand the experience that callers will have. It removes a lot of the worry that users had about how it will behave, because they just spoke to it as a caller. And then you get a couple of weeks for free to try it. And this helped a lot bring users over that worry, and give them that experience in one click. Another thing that we had to do is to give users complete control over behavior of the assistant. So who does the assistant answer to, right? Is it contact? Is it non-contact? Does it answer spam callers? Does it not? And how the assistant answers. How does it behave on calls? Does it, like, you can do it per categories of callers, etc. Those things really improved the conversion rates of amounts of people who are willing to try it and then stay with a product. So those were a couple of our most difficult challenges. Obviously, there were a lot more challenges that I won't have time to speak of today. A lot of monitoring all our lines as we get millions of phone calls, and you need to make sure they are connected and working great. Availability, redundancy, real-time processing demands. We need to manage multiple protocols, right? SIP, WebRTC, some carriers support TCP, some UDP, really alphabet soup here. And it's telecom regulations, data privacy laws are very strict in some countries, like India, for example. You need to adhere to very strict regulations, and that is tough on innovation, right? You don't get access to all the data that you want to improve the product, etc. So a lot more challenges along the way. But what we found is that every time we faced a new challenge, instead of just solving it, we tried to understand how we build a system around it, right? So our custom backend has every challenge here that you see. We tried to build a process out of it and almost sort of an automation around it. So when we launch in new markets, new languages, it's already kind of built in, and we just need to do that process instead of rethink it through from the beginning. So 4 years ago, we stood before a challenge of creating a phone assistant in many languages, super cost effective, and still keep it smart and innovative. And it looked, really, to be honest, it looked impossible. But today we kind of did it. We launched it. It works. Users are happy with it. And looking at that process, I understand that working on impossible things is probably the most fun thing to do, right? Because when we started, the market wasn't there. The carriers in India didn't support what we needed them to support. The costs of LLM inference were too high, right? But as we started working on those impossible things, the market, the companies we worked with, and the technology moved along with us and allowed for some challenges to be solved. And at the end of the day, when you look at it, it works, and we made it happen. And if I have one thing that I'm sure of, is that I'll always want to work on impossible things. That's the most fun thing to do. And if it's already possible, where's the fun? What's the point? Try to do this impossible stuff. It's obviously a lot of fun. And that's pretty much it for today. Thank you for jumping in.